if the density of the earth is doubled, keeping its radius constant, then acceleration due to gravity, present value 9.8 meters per second, means acceleration due to gravity what we are taking is 9.8. So let us see what is asking here. He is asking if the density of the earth is doubled. So we are doubling the density, then keeping the constant acceleration due to gravity. What is asking us? Let us see. So here he is telling us the value of G, as we know according to a formula, G is equal to G into m by r square, where G is the universal gravitational constant, m is the mass of the earth, and r is the radius. If the density of the earth is doubled, means D is doubling, keeping the volume is same, then the mass also gets doubled. Like as we know that the formula for density is equal to mass by volume. So if this is constant, not changing, if D increases, density increases, mass should also increase. So that's why as the density is double, the mass will also become 2m. So the value of G will be doubled. That is 2 into 9.8, which is equal to 19.6 meters per second square. So acceleration due to gravity now it will be equal to how much? 19.6 meters per second square. Okay, next question. The formula of gravity at a height h above the earth's surface is, means what is asking here? He is asking about what will happen to the gravity as you move to a certain height above the earth's surface. As we know that as we go high, the gravity will be decreasing, and we see the formula, that is G dash is equal to G into R by R plus H whole square. Means at a height the gravity will be equal to G into R by R plus H. Means here if you observe, the denominator value is more, then the fraction will G dash will become less. Means acceleration due to gravity at height, as you move high, it decreases. Next, the force of the gravitation between objects of ordinary size kept at a distance of 1 meter from each other is often the order of, means what will be the value when you take the distance. So here you can observe the calculation part. Distance between the two objects of a ordinary size, means some size, is 1 meter to find. So the force of gravity is taken by using the formula F is equal to G into m square by r square, because m into m, actually we know the formula, F is equal to G into m1 m2 by r square. But here m1 and m1 and m2 are same, so that's why we are taking as m square. Then substituting the values, 6.67 into 10 power minus 11 into 1 square, because he said the mass of 1 and the distance is also 1. Ordinary size of mass is taken. So if you take, the value will be this one. So it means that the answer will be 10 power minus 11 newtons. Next, a stone is thrown vertically upwards and caught at a point of projection after 10 seconds. The time taken by the stone to reach the highest point is sorry. So let us see once again. A stone is thrown vertically upwards and caught at the point of projection after 10 seconds. The time taken by the stone to reach the highest point is. So here if you see what is telling according to our formula, the maximum height reached by the body is given by the formula S is equal to S is equal to ut minus half gt square. So, and when it is projected, S2 is equal to gt square. Why? Because as we take, when it is freely falling, the initial velocity is 0. And considering these two values, you get the total time is 10 seconds. So time for the highest point is 5 seconds. Why? Because we know the time of ascent is equal to time of descent. So the time of ascent is equal to time of descent. So that's why total time is 10 seconds. So the answer will be 5 seconds. So what is the answer? 5 seconds. Next, a wooden cube floating in a water supports a mass m is equal to 0.2 kilograms. On its stop, when the mass is removed, the cube rises by 2 centimeters. The side of the cube is so density of the water is taken into consideration. So let us see what is the formula. We know a body is floating means it has some buoyantic force. So what is the buoyantic force? As we know, the buoyantic force is given by G into AH, where G is the gravity, acceleration due to gravity, A is the area of the object, and H is the at what depth or what height of the body is taken, is equal to mass into gravity. So here, immersed in fluids, H is 2 centimeters. Where 2 centimeters convert, you get 0.02 meters, means converting centimeters to meters. By taking the formula D is equal to under root of m by rho h, we get the answer 0.1 meters, which is equal to 10 centimeters. So the buoyantic force is 10 centimeters. Next, the 2 point masses, each equal to 1 kg, attract one another with a force of 10 power minus 10 newtons. The distance between the 2 point masses is, where we are taking G is equal to 6.6 into 10 power minus 11. So here if you see, according to the Newton's universal gravitational constant, F at gravity or force is equal to G into m1 m2 by r square, and force of gravity is given as 10 power minus 10 newtons. And if you take m1 is equal to m2 is equal to 1 kg, and already we know the G value. So when you substitute these values in this given equation, G into m1 m2 by F, we get 0.66, where r square is equal to 0.66, where r is equal to approximately 0.8 meters. Converting it, you get 80 centimeters. So the answer is 80 centimeters. Next, two bodies of masses 10 kg and 100 kgs are separated by a distance of 2 meters. So what is given here? He has given For us, one mass is 10 kilograms and the other mass is 100 kilograms. And they are separated by a distance, means the distance between these two objects is 2 meters. Here, G value 6.67 into 10 power minus 11 Newton meter square per kg square. Then he is asking us the gravitational potential at the midpoint of this line joining. Means if you take, these are the two bodies, these are separated with, what is the gravitational potential between these two bodies? So let us see. Mass of one body is taken as h 10 and the midpoint between these two distances we can take as, so mass of one body is taken as 10 kilograms and G value 6.674 into 10 power minus 11 and midpoint distance means as it is given 2 meters, half of it, that is 1 meter. Then gravitational potential, we know that given by V is equal to Gm1 by R1 or Gm by R. Substituting these values, you will get 6.67 into 10 power minus 10. And second body, if you take, M2 is equal to 100 and same gravity and R will be same because midpoint. Same formula if you use, just only we will change the mass of the body, that is M2, and you get 6.674 into 10 to the power of minus 11 into 100. So if you take here, it will become as 10 power minus 9 joules per kilograms. So taking these values V1 and V2, V1 plus V2 is equal to these both the values what are taken, we'll add it. So the finally we'll get the answer as 7.34 into 10 power minus 19. And if you consider this, you get as a 7.3 into 10 power 7. So why? Because these values if you substitute, you will get 7. Okay. Next. A certain year is 29.5 times the Earth's year. Means the time taken by the certain to revolve around the sun is 29.5 times than the Earth's year. How far is the Saturn from the sun? If the Earth is 1.50 into 10 power 8 kilometers away from the sun. If you are taking this Earth's distance is this one from the sun, and how much far the Saturn is. So as already we know, the time taken by the Saturn is 29.5 times. That's why we are taking as 29.5 times of Earth. So where T is called as the time taken by the Earth to revolve around the sun. The next, the distance from the sun to the Earth is given as 1.5 into 10 power 8 kilometers. According to the Kepler's third law, the time taken by the body while revolving around a certain object, we know the relation is T square is proportional to R cube. T square is proportional to R cube. That is, time taken by the Saturn by the time taken by the Earth, square of them is equal to cube of the distance between them. So we take RS, that is distance of the Saturn, sending the component here, we get TS by TE 2 by 3 R cube. So when you substitute these values, what are the values? Radius of the Earth, that is 1.5 into 10 power 8, and comparing that TS, time taken by the Saturn, 29.5 by TE and time taken by the earth, this both will get cancelled. Then you will have this value multiplied with this value, that is 1.5 into 10 power 8 into 9.41, and that is 14.3 into 10 power 8. And if you take this value, we get 1.43 into 10 power 9 kilometers. So 1.43 into 10 power 9 kilometers is the distance of the Saturn from the Sun. Next, the eccentricity of Earth's orbit is 0.0167. Find the ratio of its maximum speed in its orbit to its minimum speed. So when you take this eccentricity, he is asking us what is the ratio between the maximum and minimum speed. So when you take the given value of eccentricity, already he gave, E is equal to 0.0167. According to our formula, the ratio of V maximum and V minimum is taken as 1 plus E by 1 minus E. We take as 1 plus E by 1 minus E. So if you consider this 1 plus E and 1 minus E, 1 plus 0.0167 by 1 minus 0.0167, if you divide, you get the value, that is 1.033. So now the ratio of this maximum and minimum is 1.033. Next, the value of acceleration due to gravity at a depth b inside the earth, means as you move inside the earth, what will happen about this acceleration due to gravity? As already we know, when you go deep into the earth, the effective mass of the earth decreases, and when the mass decreases, automatically the acceleration due to gravity also decreases. So here we can say that the value of decreases with depth, means how much deep you go into the earth, that much gravitational forces will be affected. The reason is the effective mass. The total mass, if you take into consideration, the effective mass will be reduced.